Oh, howdy. Sure can.
How's it going?
Fantastic. Yourself?
Pretty good, pretty good. Thanks for taking your time and talk to me.
Yeah, no problem. Glad to be here.
Um, so let me tell you a little bit about myself and Vivax Metrotech and kind of what we do, and then we can go in a little bit about what you can bring to the table and so on. So we're a relatively small company. We're based in Santa Clara. We have about 20 to 30 people locally. We have one site in or two sites in the UK, I should say, where we have about 7 engineers right now. It's going to be 10 soon. And then we have a large site in Shanghai where we have over 100 people with about, I would say, 10 engineers or so. Um, so we make underground cable locators. That's kind of the main thing we do. It's electromagnetic sensing, AC currents. They're used by utility workers like PG&E to locate their utilities underground. So there's a law that you should call 811 before you dig, and there's a lot of commercials everywhere. So call before you dig, and it basically they have 24 hours or 24 or 48 hours to mark out where this stuff is on the ground. So we deliver the instruments that they use for that. Um, we also do sewer inspection cameras. So there's hardened cameras on the push rod that you send down in sewer pipes, and you um, inspect them and see where the problems are. And obviously that's more for plumbers and contractors that clean stuff. Um, so the engineering team on the engineering team side, we have our mechanical design team is in Shanghai. We also have a little bit of software and electronics engineering there. UK does both electronics and software, and here in the States, we've done mostly software and electronics, and mostly management from here.
Mm.
So we're looking to increase the team here with 2 people to get more electronics and software over here as well. Do you have any
Cool.
question about the company and what we do?
Um, Not off the top of my head. Although I was sort of interested, does the position require any kind of knowledge of waves, for example? Because I was thinking about a ground penetrating, I don't think radar's the right word here, but
No, there is such a thing as ground penetrating radar.
okay.
We haven't really gone into that. There's too much user interpretation required for that.
Oh. Mm-hmm.
So it's very difficult for a plumber or contractor to actually understand what you're seeing.
Yeah.
So the people that use our equipment, they're minimum wage or just above minimum wage. So it needs to be really easy to use,
Mm-hmm.
uh, quick instruments. So it's yeah, a little bit different kind of user set there. So
That makes sense. No,
okay.
I'm good. I think I've got a
All
firm
right.
grasp
So
on what it is.
tell me a little bit about yourself and what you want to do. And
Well, I'm Sacramento based. I'm graduating next month, so
Okay.
actually almost exactly a month. The 23rd is the graduation ceremony. I'm
Okay.
getting my bachelor's in electrical engineering with a specialization in product design. My focus is actually in control systems,
Okay.
which is kind of all about analyzing.
Yeah.
My senior project is actually working on a portable EKG machine, which has been a whole lot of fun. And I think that's been
Okay.
kind of an interesting introduction to meeting some of the safety standards because to make a medical device, you have to meet your our biggest one was our 60601-1, which is making sure that you have a safe amount of current leakage and whatnot, that you're not going to be electrocuting the customers.
Yeah.
Uh, I'm really interested to be working in something that's like hardware based. I think that'd be really
Yeah.
interesting.
Okay. So how much like schematics have you done and layout and stuff like that?
I've worked a lot with PSpice, which is very
Okay.
similar to the Altium Designer from a cursory glance. So
Yeah.
I've played with a lot of that. I've built a lot of, hands-on breadboards for experimental labs. I've played with a lot of oscilloscopes. I have my
Okay.
own mini oscilloscope for home
Uh,
usage that I've played with.
yeah.
Uh,
Yeah.
and then I've also been primarily responsible for troubleshooting our circuit in our senior design EKG machine because
Okay.
that's a series of three microchips and a microcontroller. And
Right.
I've been the one who assembled that and made sure that the connections were working and playing with the oscilloscope to make sure that signals were coming in through the leads and then actually doing what they're supposed to and getting filtered as they're heading into the microcontroller.
Okay. Interesting. Interesting. Good. Sounds like fun.
Oh, it's been a
So,
blast.
so did you do programming as well, or mainly electronics on the electronic side?
For this project, I've focused mainly on the electronics, but I
Okay.
do have a decent amount of programming experience under my belt. I've played with
Okay.
a lot of C, I've messed with Java. My current job, I'm actually a clinical research data assistant, but what I'm doing is I'm
Okay.
using MATLAB to create code that's basically analyzing medical data.
Oh, okay.
And I've been
MATLAB.
basically leading on that project. I know it's not a real coding language, but
No, but that gets me curious. Why pick MATLAB?
actually, MATLAB is what most of the Office uses, and it's kind of what they had their basis built in. So they kind of
Really?
wanted us just to continue with it, and I went, well, if that's what we're using, okay, I'll make it work.
Okay. Yeah, because I mean, Python does almost exactly what MATLAB does, but it's free and
Yeah, they already had the MATLAB licenses, so they were like, oh no,
oh,
MATLAB's what we
okay.
use. But
Uh-huh. Yeah,
yeah,
that's the big hurdle to get the MATLAB licenses.
yeah, but they already had them set up because they used them for a couple other projects. There's a lot of
Okay.
weird design going on in that department, to be honest.
Yeah.
Yeah, so
Interesting.
I roll
Interesting.
with it. I work with what I'm given.
All right. Cool. So I do have some more more technical questions here. So let me send you a link to. I have found this online whiteboard, which is a
Oh,
great thing. Let's see if this works. It's a little bit slow. There we go. I hope that was the right. In the bottom of the page, when you click on the link, there should be guest login or something like that.
yep.
So you don't have to register because it makes no sense. They just want your email. So, all
Okay.
right, there we are. All right, so let me see here. So let's say we have a signal source that's referred to ground or signal. It's a not a very good source. So it has a source impedance of 1 mega ohm. See, and the actual source is a 0.1 millivolt RMS, and it has a 1 volt DC offset. Come on, network restored. Okay, so do you see that?
Yeah.
See. So my question for you is, how would you design an amplifier for that amplifies the AC signal with 20 dB?
20 dB is going to be 1 decade, so I would be really just throwing ideally a BJT in front of it.
Okay.
Or some other kind of op amp. I would have to double check my notes to have the exact numbers because I do not remember the ratios off the top of my head.
Okay. So how would you hook that up though?
Something like this where I'd have this going into a positive output. We have our negative here. Ooh, this is not. This is hard.
Yeah, it's not ideal.
Yeah. And then I want to say we're going to have our we're going to connect to the negative input over here.
Okay.
Again, I don't remember the exact ratios for these resistors here that would be giving me 20 dB. I would have to double check my notes there.
Okay. So how would you make this such that it does not gain the DC voltage?
We could just drop a capacitor in front of the positive input, I believe, and that would cut out the DC completely.
Okay. Is there any problem with that?
That is going to be interfering with our AC. So, if we dropped a capacitor at the end instead, it wouldn't be modifying the input.
Mm-hmm.
So that way we could be cutting out the DC signal at the end.
Okay.
Did we not want to remove the DC and just amplify the AC while maintaining the DC offset?
Just maintaining the DC offset and amplifying the AC.
Oh, okay. Then a capacitor is going to be removing that element. That's not going to work here.
You can set the size of there's the round circle.
Oh yeah, I see it there.
It's not the best UI, but gets the job done.
Yeah, it's not bad. I apologize. I do not remember this off the top of my head. This is the type of thing that, given me 10, 15 minutes, I could look it up and remember it, but
Okay.
I haven't honestly looked at an op amp since last semester.
Okay. All right. So let's say we've done our op amp circuit. Now we want to add an ADC to it.
Mm-hmm.
What's involved from your op amp here until you go into the A to D? What do you need to do to condition the signals, and what do you need to think about?
I'm familiar with the ADC itself. You need to be aware of your quantization levels because we're
Okay.
going to be putting in an analog signal and getting out discrete information. Uh,
Mhm.
for putting in an offset. Hmm. I'm not familiar off the top of my head because in my project we were using the ADS 1293s, which had ADCs built into them. So it was a
Okay.
lot of this big portion of the circuit minimized it down to these smaller portions, so that once it ran through the series of high pass, low pass filters, active and passive, that it was going into our ADC and getting put into our microcontroller. All that we had to do was determine what the level of quantization coming out of that was, so that we knew what data we were sending over to our main board.
So you had a chipset that was doing the filtering, or
Yes.
I see, I see. So what kind of filtering do you need for an A to D?
Uh, well, we had high pass and low pass, but these chips were actually specifically designed to be reading in leads for an EKG machine. So they
Okay,
were basically just trying to cut out up to the low ends of movement, which is going to be muscle movement and whatnot, and the high end noise is going to be things coming from, you know, power in the walls and whatnot. So that at the end we
okay,
had a range of frequencies coming through that was going to be what we were looking for.
okay. So in terms of an A to D, where do you want to cut it off on the high side then?
For our purposes, we were looking really low because we were looking
Okay,
at heart ranges, so we weren't really accepting anything over like 200 hertz,
I see.
250.
So at what sampling rate do you have to sample that to get a good resolution?
Nyquist says that we wanted to be sampling that at double whatever rate we're actually looking for, so we were pushing that up to 500 to get
Okay,
good resolution.
okay. All right, so let me move this up a little bit. Of course. So I'm gonna, let's see here. So next question here. So let's say you have to probably move this up a little bit. So
Oh,
we have
okay.
this power supply,
Hmm.
and this has an output. We want this output to, we want this power supply to have a logic signal control with a high level and a low level. And we want high to equals 5 volt on the output and low to equals 3.3 volt on the output. How would you design that circuit?
Hmm. So we have a power supply and we're inputting a low signal or a high signal. We want the high signal to be 5 volts and we want the low signal to be 3.3 volts.
On the output, V out.
Yeah. Hmm.
And this the low and the high is just normal TTL logic or whatever logic level you drive your system with.
Hmm. So when it's high, assuming that the supply is putting out 5 volts, we would let it go through. But if we wanted to lower that, we could just put some resistors when it's low to give it a voltage drop across those resistors so that at the output it's lower. Um,
So how would you draw that?
mhm. So 5 volts should just be going through just fine, but then it breaks here we have a resistor that goes to the 3.3, and that's going to give us our appropriate voltage drop. What's going to tell it here whether or not it's high or low?
Well, I mean, this is it's a control into the power supply, right? So you want to tell the power supply to change. Does that make sense?
I'm not certain I'm familiar with this form of logic control. Telling the power supply to output high or low if it
No,
has.
it has basically a power supply that outputs 1 voltage, and a logic signal that controls the voltage between 2 different levels. So you have when the logic high is in, you get 5 volt on the output of the power supply, and when it's logic low, you get 3.3 volt. How would you go about doing that control?
So are we thinking something as simple as a gate where when it's high it's one thing and one thing it's another? Something simple like an AND gate that one side is always high, then when it hits the low on the other, it's putting out 3.3, and when it gets high, it's setting out 5.
No, you want to save. You want to save. You only want one power supply. Otherwise, we would just take 2 power supply, right?
Mm-hmm.
So you want just one power supply driving 2 voltage.
Oh, okay. Well, then in that case, we could just use. Get a finer tip. So this is our 5 just going through. So that'll be high, and then here we could put a NOT gate so that when it goes through, low won't be going to 5 anymore. And when it's low, this will go high, and this will be going to our 3.3. And that would be using a resistor to drop the voltage there. Or assuming we have a 1 voltage input, we would have our op amp here to bump it to 5, and an op amp here to bump it up to 3.3.
But all right. So let's say we want 10 amp output. Come on. No ideal control on this, but okay. So let's say we want 10 amp output on this power supply.
Mm.
Would that work?
No, that's going to be modifying the amperage with my design.
How do you mean modify the amperage?
An op amp is going to be outputting the higher voltage with a different amps than it's going in with. Assuming if we're putting 10 amps in.
Yeah, I want 10 amps out, right?
Yeah, so that's going
5
to be
and
changing that.
3.3. So how much do you think an op amp can drive?
Probably not 10 amps. That's a lot of power.
I would agree with that.
Yeah, I've never worked with anything that puts out that much power.
Yeah.
I'm surprised to see anything more than a microamp usually, or milliamps.
Yeah, it depends. We have transmitters that output what's it, 200 plus volts and then 1
Oh,
amp.
man, that's something.
Yeah, you don't want to touch it.
Oh no, those are scary to play with.
Uh-huh.
Now, I haven't had the pleasure of playing with anything with that much power yet.
Right, but that's okay. So what else do you think? So how do you normally control the output voltage on a power supply?
Increasing and decreasing resistances,
Okay.
or a little more obscure, but if you're trying to move that power a long distance, you throw it through a transformer, but that's when you want to drop your voltage and keep your amps high.
Okay. So what are the resistors controlling?
The resistors are there to drop our voltage because the amps should be staying constant across them. Current shouldn't change across a
Okay.
resistor.
So what if the current varies? So
For
normal power supply, how do they regulate the power on a power supply?
I think most power supply is going to be putting a alternating current, and if we want to keep 10 amps of current,
So this is a battery. Let's see.
throwing in an inductor would resist the change in current, but I'm not certain if that's our goal here.
No, so the goal is just to tell the power supply I want 5 volt or 3.3 volt.
Yeah. So I should think that this NOT gate should be distinguishing our 5 line from our 3.3 line.
So what is that? Like a gate or?
Yeah, it's a NOT gate, so that it'll
Okay.
be low, keeping the 3.3 NOT going when it's sending in high, so that we're getting our 5 out when it's high and our 3.3 out when it's low.
Okay. So, but a gate, how can that handle power?
Mm. I'm not. Gates don't scale up well, do they?
No, usually that's just logic. TTL.
Mm. Hmm. I can't say I'm familiar. I haven't worked with higher voltage systems or higher power systems if we're outside of logic. Could we use something as simple as a mechanical gate, like a physical gate that actually switches back and forth?
Well, I mean, you're switching the power supply, so the idea is that you mess with the power supply, right? The output needs to be able to switch.
Mm-hmm. Um, I'm not certain how to approach that. I don't think I'm familiar with this.
So usually a power supply has a reference, right? Reference input that
Yeah.
you put a resistor divider to, right?
Mm-hmm.
Um, so this reference voltage, so the power supply will hold that reference voltage at whatever voltage you need,
Mm-hmm.
or whatever the internal reference on the power supply is, right?
Yeah.
So how would you use that knowledge to be able to switch between 5 and 3.3?
If it's keeping itself at its reference. So this is a logic system where it knows what it should be.
Well, I mean, it's a power supply, right? So the power supply will bring the output voltage such that it matches the reference, its internal reference. That's how I would say 99% of all the power supplies work, whether they have a fixed output or a variable one, but in some way, shape, or form, they're measuring the output and then comparing to its internal reference and controlling it that way.
Okay. Variable output is going to make sure that it's matching its internal switch.
It's like an op amp, right?
Yeah, in the sense that
It's
it's reading its
one of,
output.
this is one of the inputs, and the other input is internal reference, and it's gonna drive that output of the power supply to match it exactly.
Hmm. So we need to find a way to change that so that it knows to match it. Hmm. Hmm. Yeah, I'm sorry, I'm not certain.
Okay. So suggestion would be to just take a resistor and add that to here, and then you drive that from your logic level. So in one
Oh,
case, you have 5 volt here, you have the Vref here, you have what do we say? You have let's say we have 3.3 volt here from the logic level, and you have ground. So you just have to calculate the R such that that matches, right? And then when we go low, guess that it's not gonna work, is it? So we have to have an inverter first, because if when it's low, you want this high, and then when you need the reverse logic, otherwise the reference high
oh,
needs to be at the high level, not the low.
yeah, yeah, just like an op amp. Okay.
Yeah, so it's basically just a resistor network that you need to control.
Yeah.
So
Hmm.
okay, that was all my questions. Do you have any more questions for me?
Um, not off the top of my head. I think
Okay.
I'm got a pretty good idea of what the business is, and
Yeah.
I'm interested.
Okay. So I have a few more interviews this week, so I'll probably make a decision sometime next week.
For
And
sure.
so, well, I'll let you know either way.
Sounds good. I appreciate it.
Okay. Yeah. No worries. Okay. Any more questions for you?
Nope, I'm good. It was great talking to you.
Okay. Yeah. You too. All right.
Thanks.
Thanks.
Bye.
Bye.
Love you guys.